those feedbacks you were referring to, that sometimes we come back with bug fixes or strange types from the TypeScript part, is effectively what led to this type of talk, and kind of exploring the cross pattern between Scala and TypeScript. Clearly, I have to say, up to now, it has been unfair. I mean, the amount of contributions you guys have made on the ZIO side and the amount of work that was involved in porting the stuff are completely on two separated levels. But what was very interesting is precisely what Adam said. Sometimes on the TypeScript side, the type system actually hint on a few problematics that the Scala 2 compiler does not. And I think indeed this is an interpretation for ZIO in basically in Scala 2 and with the features of Scala 2. So as Adam explained before, it takes a while to adapt the ideas into a language. And I have to say, ideas are much bigger than languages. And the ideas that you guys have contributed to ZIO are much bigger than the library itself, I personally believe. And they go in the direction of really making functional programming something practical, extremely practical, them to the day-to-day business app development. And I think it's a very pleasant user experience to use ZIO. So you might ask, why in the hell do we make a TypeScript port in the first place? We could use Scala.js and everybody would be happy. That's the simple answer. We could have, and in fair honesty, we tried, but Scala.js still has a number of problems if you want to kind of integrate very well with the JS ecosystem, and you want to provide a native first experience that is thought to run on a JavaScript virtual machine rather than on a JVM. Mainly, there are a number of design patterns that are used in ZIO for Scala that works extremely well for the JVM and for that type of environment. They don't quite work extremely well within the JavaScript side. I have to say, as of backend, it would work extremely well too. But as a matter of front end, for example, you have a lot of bundle size added by default, because obviously Scala is a language that also has a runtime aspect. TypeScript instead is purely static, and everything is erased at, before runtime, and the code is very close to JavaScript. And also the very different aspect is the interoperability with the NPM ecosystem. So if you want to breach on the NPM ecosystem, we thought the best idea would have been a TypeScript code base. At the point in time where it's almost funny, because for a period of time, the two projects, ZIO and Effect, actually were running almost on parallel, because I believe the first internal release of Effect was like 1 week after John added the third parameter R to the environment. But the code bases looked very different. At the beginning, the TypeScript implementation was just a joke and almost a proof of concept, proof feasibility. While in Scala, you already had an extremely well-designed IO data type with a lot of functionalities on top. That situation effectively ran for quite a while, and we discovered the feasibility effectively within the TypeScript language. And there are a lot of adaptations that needs to be made. One in particular is in TypeScript, we don't really have any sort of explicit parents and notation. So many of the patterns used in ZIO, we kind of can't use them. And on the other side, like the Fluent API of having all the functions within a data type, like in ZIO you do ZIO.succeed, and then you can do .flatmath, .catchall, blah, blah, and continue to go on. That is made by either kind of implicit resolution mechanism, or they are directly within the data type itself. If you do that in TypeScript, you end up with everything compiled within the same class, and the bundle will explode in size. So we had to figure it out, a lot of patterns to avoid that type of scenarios. And the status quo functional programming in TypeScript was actually FPTS, which emulates higher kind of types, I would say at a very basic level, but that was the status quo of FP. There was nothing around to actually do application level stuff. In Scala, still, you had cuts, you had Scala Z. There's kind of a prior history which already kind of developed the environment and developed the ideas. And also, what I thought really big in ZIO at the beginning, when John proposed the third parameter, was, yeah, that crunches a lot of boilerplate in Scala. But Scala already has higher kind of types, and the boilerplate is not so much. In TypeScript, we are running on a simulated environment where the boilerplate is 100 times bigger. And doing something like tagless final in TypeScript was absolutely impossible. Extremely verbose, and you just lose inference, and anything else doesn't work. So the process of adapting to a specific language has been actually quite useful, because the restrictions of TypeScript are in some cases similar to the restrictions of Scala. Like, you guys don't want to use a lot of higher kind of types, because at the end of the day, using concrete types give you better developer experience. We have it extremely verbose. The restriction is not at the same level, but the solution goes on the same direction, removing the higher kind of types. So there was a lot of learning. And at some point in time, we decided to drop the project that was inspired by ZIO and actually do a full port of ZIO, because we've realized you guys are making a lot of changes, a lot of bug fixing, a lot of innovation. And if we don't have like the data types encoded almost one-to-one, it's gonna be impossible to catch up, and it's gonna be impossible to produce at least even the same amount of features, even in a simplified set, because obviously JavaScript is a single thread. We don't have like thread allocation. Our runtime engine is a little bit more simpler than the ZIO one. But by keeping the code extremely close, we are able to follow what you guys do in the Scala sense. So what our work was actually do it in TypeScript, but as close as possible to a Scala one. And the nice aspects is Scala 3 adds some language primitives that we already have in TypeScript. So stuff like dealing with unions on error types, or dealing with intersection for environment types. We have had that for about 2 years in trying to encode on top of that. So some of the patterns, I believe, in Scala 3 could effectively borrow something back. And obviously, the project is extremely preliminary, and I've just made a single Scala file just trying out some encoding. And at this point in time, it's even buggy. At the type level, it doesn't work extremely well. There are Scala issues open on at least 2 different bugs. That one you spotted on TwitterKit, and the other one is on an intersection where a type gets erased and it shouldn't. So I do agree with Adam. It's still kind of looking a lot forward to imagine a native experience in Scala 3 for a full, or like a ZIO completely developed in Scala 3. That's definitely gonna take a while. But there are some patterns that probably at some point in time could be made better. Mainly, there are a lot of times where ZIO uses variants, where actually variants, I believe, is kind of an non-appropriate solution. The actual, for example, when you're mixing 2 operations, where one operation might fail for a reason A and another might fail for a reason B, you're really not saying those fail for a common type parameter. That's not what you're trying to express. What you're actually trying to express is the composition can fail for either reason A or reason B. It's much clearer if implemented in terms of union types, and that would allow not having the variance at the general level, at the definition level. And that's very interesting, because what I figured in working in Scala, I worked a lot on the Scala side too, more as a user's perspective. I haven't contributed a lot in libraries in Scala. But what I figured is variance is a nice property. Type inference is a nice property. Use type inference and variance together, and it's a nice recipe for disaster. That's what I've personally realized multiple times. In TypeScript, I almost never realized the same. And the reason is the types are not kind of invariant by default. They don't mesh together to a top type like an any or like a nothing, depending on if you're using a covariant or a contravariant type. So you don't get these strange behaviors, and you can borrow a lot from the type inference. And it's actually the type of API that we are trying more to expose on the TypeScript side. We're almost aiming not to write types manually, almost at all, which at some level sounds strange. And if I were to express the same sentence a few years ago, I would have probably shot myself. And I kind of never believed that at some point I trusted like this kind of inference leads to a safer system. But I sort of realized that that is the truth in many cases. And not annotating the type parameters in every function actually is much more flexible for many other reasons. But obviously, this in a code base that uses variance would definitely be almost an impossible thing to do, because anytime you mix something that's not exactly matching to a common type, then it's gonna explode to either any or nothing. So I think that's the overall introduction on kind of the reasoning behind of the doing it in TypeScript, and the sort of story of how things sort of mesh together. And at this point in time, we have almost the one-to-one port of every single data type that is in ZIO, including the 2.0 types like hub and the experimental streams, which, by the way, is insane. It's something like, yeah. Sorry?
Wow, that's a lot of data types. That's all.
It is. And you are discounting one aspect. TypeScript doesn't have the native stuff like a list or a hash map.
Sure.
Or those basic data types that you have in Scala. So there's all ZIO plus
all the
radix
jump.
balanced linked lists, hash map based on radix balanced trees, and all of the gluing of missing pieces, because obviously you guys make a lot of usage of the very proper data types that exist in Scala for doing things in a creative way sometimes. And to emulate that in TypeScript, sometimes it was like, okay, to do this, I see how I do it, but it's like, it's missing 2 months of work before I'm even gonna be able to express this. And that happened frequently. And at some point, I was on the impression I could integrate streams without chunks. It turned out I needed other 2 months of work to reintegrate all the chunks and do all the stuff. But anyway, there are a lot of data types. And every time you add a new data types is always a fun experience, because it's an idea that you say, yeah, okay. It's so, like, the new streams are insane. Personally mind blown by the encoding of the new streams. And it's like, I remember Adam saying on a channel, it's an encoding that shows something about the actual meaning of streaming computation. Yeah, it is true. And up to now, no other encoding kind of expressed that. So sometimes we really have huge realization when you add data types like, wow, it works extremely well. And those, I believe, are ideas. They have nothing to do with the language. You could port it in a third language and it would still look extremely good, which is why I'm extremely excited seeing ZIO more as a sort of movement in trying to make functional programming accessible, extremely practical, regardless of the environment you're targeting. I strongly believe this is a very good goal, and if we share ideas, it's only gonna be a productive. It's only gonna be better. trying to encode these in a totally different ways in 2 different languages, I don't know if it makes a lot of sense. It's better if we keep stuff as similar as possible so the innovation can happen in steps. So that's my my general description of the development that has happened on the library and what we went through during the last years. Now I'd like to show a little bit of code. It's not gonna be extremely long, and I'm gonna do it using an API which is available since last week. So hopefully it's gonna go well. Good. Can you guys see the font size? Should I raise a little bit more?
Yeah, maybe one more bigger, but it's good now too.
A little bit bigger like that?
Yeah, that's perfect. Yeah, that's
perfect. So first of all, one of the key differences is the name of the core data type. In our case, it's called effect, and in your case, here it's called ZIO. The reason this is not called ZIO is because ZIO is the full name of the library, and I really didn't want to steal any the keyword. I didn't want to take the same keywords as you guys do. So the other name is effect, but this is kind of the only creative name that we are using. Any other name tries to mirror almost one-to-one what you guys have, with maybe slightly different interpretations, but we try to be as close as possible, even in naming the actual API, so people can study one system and port as much as possible in the other system. That's another goal we have. Introducing effect should be a good introduction to also begin using ZIO if you're using Scala in a different code base. Like if you're using Scala in a different code base and learning ZIO, it could be a good intro to use effect on your TypeScript code base. So definitely keeping things as close as possible as of naming conventions and API usage. I was very happy to see that ZIO 2.0 is actually renaming a lot of stuff, and in ways that are sometimes even more clear. And I believe effect is kind of in between the naming of 1.0 and naming of 2.0. We yet haven't declared a fixed 1.0 release, so for us, we can break stuff. We are free to break stuff. It doesn't matter. So anyway, we in TypeScript have, usually you use namespace imports, where you import the full module in a sort of global namespace. And the basic idea is that in this namespace, all the functions of the modules are exposed. So in here you have stuff like the succeed function, that in ZIO you're effectively merging effect total and succeed in a single notation. Here, one core difference: in TypeScript, we don't have lazy parameters. We don't have lazy definition, so we have to have 2 variants: one strict, one lazy. So you will find succeed with, which is the lazy variant. So let's say we go succeed with, we can succeed with a lambda that returns 1, and the basic API, which would be terrible to use, is this type of things. This is like a flat map on ZIO side, which here A would be a number in this case, and I can say succeed, for example, A plus 1. Obviously, this type of API is sort of unusable. You can't write directly in terms of this API. It's terrible to use. You would have to, you lose, I don't know if you can imagine a mixture of like 3-4 concatenated stuff in this manner. You just lose track of whatever is going on. The good aspects of this API are a few things. Functions are all independent, so they can be shaken away, and the lambda allocation is minimal. We're not allocating any additional closure. We're not currying anything. So that's basically the minimum effort as a matter of the shortest form that a JavaScript would accept as the best case scenario. So that's kind of our target. Obviously, we don't want to write in this style, so we have different styles to write, but you can expect the compiler plugin to rewrite it back to this version. So ideally, in code, in compiled code, you're always going to have this type of code, even if you use an alternative API, which is more familiar. The API that we have used for a long time is what is called a Pipeable API. I should mention type inference in TypeScript works from left to right. So it starts inferring variables from the left side. And it's not like Scala that on a curried function you cannot specify generics on the curried one. You can specify generics at any curried level. So it's very important for TypeScript to work left to right. They don't infer in any other way. Any other type of inference will have anything mapped to something like unknown, and it wouldn't compile. So we have to still keep this sort of left to right idea. To have a nicer API, which reads better, for a long time, a pattern introduced by FPTS is the Pipeable style, which basically we use a function pipe that composes in this way. And here we can do multiple things. This is like a function composition, but instead of being a function composition, the argument is passed as the first thing. We don't pass it as the last, because inference works left to right. So you start with the parameter and the inference works progressively. So if we take a look at this type, we have it in the return type that this is an effect that doesn't require any particular environment. So we have unknown, which is in Scala, the equivalent would be any. We have never for the error channel. In Scala, that would be nothing. And we have a result type of number, which in Scala would be
everything.
Everything, yeah. Any other and the actual stuff that doesn't quite matter. So this is how code have looked for a long time, and I think this is still a very nice API to use in many places in TypeScript, and it works extremely well, especially because you can, all of this is independent. So you can have additional function definitions in your code, and they mix exactly and precisely in the same way. We use some JS doc annotations to instruct a custom compiler plugin to know how to treat those functions. So when the compiler plugin goes here, it will say, okay, this is a pipe, it's function composition. First thing that it does, it's gonna strip out the pipe, and it's effectively gonna write these in terms of plain function composition. That wouldn't work in the, so this is the first thing that roughly goes on. That doesn't work for type inference. As you see, A here is obviously unknown, but it unbundles and it removes the pipe. The second thing that goes on, it unbundles everything in terms of data first elements, data first functions. So it effectively, it's gonna do this automatically, and your code is gonna end up looking this way at the very end.
Sorry, did you say this isn't a macro? This is just, what does that?
It is almost a macro.
Oh.
But TypeScript doesn't support macros. So we had to use an extension of the TypeScript compiler because they actually, yeah, they cheat, they have macros. They're just not exposed publicly. So there is a plugin where you can effectively use macros. They're not as powerful as a Scala macro, don't think even close to that. those macros are actually only running in the transformation step. So you cannot do any macro at the type level stuff.
But it sounds like it solves this problem, which is you just want to reorganize.
You want to reorganize things, and it solves another hidden problem that you wouldn't guess that we actually have in TypeScript, which is execution tracing. That works reliably on the JS virtual machine. That's another place where we had kind of a shock in realizing you guys in 2.0 are effectively going for almost kind of similar, slightly the same type of solution that we use, which is if you notice every function here,
as a trace,
it has a data first equivalent, which instruct the rename and the reorganization that Kit noticed. And then you have a trace parameter, which is filled with the actual trace. So effectively that does tracing via a compiler plugin, which for us has always been cost-free. And I'm extremely happy to see that this is now probably going to be the case on the JVM too, because I have some tools running on the JVM where I have tracing turned off, and I would like to sort of swap it on as soon as that is thought to be free.
Well, that's good news for us too. That yes, it's always great when you see the way someone else implemented it, and it's kind of the same way that it feels like there's a universal good idea here that we're all simultaneously.
And that it always feels very, very, very good. Another point that was like when you presented in the, I don't remember what meetup was, but at some point in time you presented the patterns, the service pattern for ZIO 2.0 with the explicit has parameters. And that was another moment like, oh my God, that was a good idea in general. Another general good idea. It's the lowest boilerplate ever. And the funny thing is in TypeScript, we just didn't have option B. We only had this option. There was no other chance. So at least that anyone has ever thought about. I don't want to make general statement, this is the absolutely only way, but this is probably the only reasonable way given into different ecosystems. We came up to the same exact conclusion. We need to embed this at compile time. Any other way would be expensive.
Yeah, maybe it's the next reasonable evolutionary step and something else will, obsolete us one day. Or we'll all fail together and then we'll have, we can commiserate with each other. We've all been so stupid.
or ideally we can obsolete ourselves.
Yes, no one obsoletes me.
That would be good too. Anyway, this Pipeable API has been a good intermediate step in going probably to what I believe would be effectively the most used API, which is something I'll show next. And that uses, again, a compiler plugin. But I do want to show at least one other pattern in the Pipeable way, because we are simulating also things like the Scala 4 in calling it, I guess, someone like Dustin in the previous live. I saw Kit raise the finger. Do you want to say anything?
Well, we've cyclically connected because you answered the question I was going to ask. Because yeah, Dom Dorn was asking if pipe or teaching is basically the equivalent of a for comprehension, and it sounds like that is sort of
sort of. We can sort of go to the for comprehension. So let's get to the point of the for comprehension. Okay. We initialize with a t.do. And a t.do is nothing more than an effect that returns an empty object to start with. So that's how you begin. Like this is the for thing in Scala. And then you use bind to bind variables to the scope. So I would like to do t.succeed 1. And the type of this now has a x in the scope. I can say y, and I now have both in the scope. Here you see an intersection type. z. Here we can access x and y, all the previous scope, x plus y. And your yield in this case would simply be a map, which effectively picks up the final result or any combination, any pure combination you might want to return. To have this effectful, you could easily use a chain here. The good of this pattern is extremely flexible in it being behind the scenes function composition. So as long as functions match, you can compose pipes up to 22 parameters. Here is another number that we have borrowed. Just for fun. That was just for fun. I've never seen a pipe longer than actually 10 things that doesn't require you actually to refactor in two different functions because you're putting too many stuff together. So definitely for the cleanest purposes, I would like to fix that to 10, but historically I like 22. It's kind of
that's really cool. Anyway, that's awesome. I think that kind of structural typing, I forget exactly what they call it, but the row typing, the structural typing where you can just, that is really powerful. And hopefully
it has pro and cons.
Mm-hmm.
It has pro and cons, definitely. It has both aspects. And I believe that the effective, right approach would be to have both of them. But in saying that, I kind of bite my lip because then I have no idea how the actual assignment rule would work in a type system that has both aspects in the same way. In that case, I mean, can you treat structurally an opaque type or stuff like that? I know Scala is going probably, they're at least thinking on something more structural. And they're kind of introducing, for example, match types. So you can do a match at the type level that goes a little bit on the structural thinking. So I hope maybe Scala 4.0 will be the embracing answer in a kind of global, the global language that everybody is going to use.
Two quick questions. One, and is can you use? Oh, sorry, what was it? I missed it. No, where'd it go? Oh, yes. Do these bound variables have proper type inference? And I believe the answer is yes. By that means a structural typing, but maybe if you could speak to that.
The inference here is extremely good because of the structural type system, I have to say. And because of the restrictions, it's once again a proof that if you work in a highly restricted environment with a lot of assumptions, you have to come up with extremely smart solutions. And the extremely closed restriction, in case of ZIO, is, for example, crazy performance on some data types that actually ended up showing blown up solutions that shows something that was originally there in the original idea. But anyway, in TypeScript, sorry, I kind of lost where I was for a second.
Yeah,
you
I think
mentioned structural type. Oh yeah, why TypeScript is that good? Because they had to type on top of JavaScript. They had almost to emulate a dynamic type language, which is, if you think about it, it's an insanity to begin with. And you have to type some types of paradigms which are extremely designed to be dynamically typed. And this turns out that as a basic, the compiler is very powerful, but they're adding features almost every single month. Like one of the recent additions is something that if I show it to you, it's gonna probably shock. So this is a data type. This is a string type, a literal. And you might think, yeah, we have literals. Fine.
But they have yes types for interpolated literals.
Here I'm saying all the strings that starts with S and are minus a number, any number. So a variable of type won't work. That won't work, won't compile.
Yeah.
That will.
That's so crazy.
So there are some deep, I believe, insanities that only in those types of things, I believe TypeScript is sort of unique in its way. I've never seen any other language trying to type this type of paradigms. And that also means it's totally unsafe. There are some places where it's totally unsafe to use. And you have to know what you're doing, especially if you're doing strange stuff. And many times, the structure, you want to kind of escape the structural type system. And effect is an extremely good case of this. If we highlight on the actual type of effect, so let's say t.effect, let's go to the source code in the original system. So this is the original definition of effect. It's actually a completely fake data type. It doesn't match with the concrete implementation of it. It's implemented as an additive of all the cases precisely as it is implemented in ZIO. But here we fake a type for the purpose of having the compiler treat this type in a very sane way. It's kind of a thing you do with heads and with a few other places in the system. But sometimes you do want to escape from the purely structural thing. And this is basically setting up in the most simple terms a unique URI to identify the type uniquely, because it's structural. If you have two things that have the same structure, they're gonna be thought of as the same type. To escape that, you use sort of unique URIs at the type level. And then you say that E should be thought as a covariant parameter, and that's going to be an output of a function. And A should be covariant, so that's the same stuff. It should be an output of a function. R, which is an environment, should be an input of a function. And the other stuff are integration with Xpure, which is the copy of Zpure from ZIO Prelude in Effect.js, but we can natively interpret a Zpure in case the types match. So this is for compatibility with that data type. Just because we need, this is another restriction of the language. You guys can run an effect synchronously sometimes, blocking a thread. It's not a good practice, but you can do so. It's not kind of forbidden in a greater sense. So if you extremely need to do so, I have seen places where that's like the only reasonable solution for other hundreds reasons why, but anyway, in JavaScript, we simply don't have this at all. It's absolutely not possible. So to encode synchronous computations, we are actually encoding on top of the same encoding as Xpure and have the two types separated. But when you interpret a sync computation inside effect, it runs the Zpure runtime. So that's the the tricks we do with structural compatibility. Type system is structural. As long as structures are compatible, the type system is gonna think they are the same thing, which concretely it's obviously all unsafe if you can't trust these actual types. And I mean, you cannot trust those types if you don't use them properly. If you consume the library, it's completely fine. As a matter of user experience with the library, it's still fine. If you go in like writing an interpreter for this type, the actual type is going to be different and the actual runtime is going to be different. But I face that like when we write stack safe interpreters anyway, we kind of back off from any type safe anyway. Like the internal of ZIO, the fiber context or the new channel executor, I don't think there's a lot of type safety around it. Like the first definitions are like erased.
Erased. Erased.
Erased. And it's almost line by line erasing safety. So I believe at the end we have the same amount of kind of type safety at the behind the scenes. The tricks we make to have an API which works are obviously slightly different. What I haven't shown yet is like raising errors. I have said that we do unions on errors and intersections on environments. I'd like to show that on the Pipeable terms, and maybe I'd also like to sort of compile at least. Let's do that now. Let's compile this file and let's at least look at the compiled output, given I spoke a little bit about these completion steps. So we've wrote in console. Hopefully. If you look at console.js, we see that X, which was our original code, is all rewritten in totally different terms. And here you see the added phrasing that we effectively. Sorry?
Those are all the little timestamps for when you wrote each line of code, right? 8:30.
The timestamps, those are line numbers, column and. Yeah. Might be fun to also add timestamps, just as a joke. Source code timestamp at compile time. When do you compile code?
We'll go to have it first or affect TS. We'll see.
Good. Anyway, let's raise an error. So let's say that here, for any reason, if number is greater than 2, this will obviously be always false, but at least at the type level works here. I'm gonna introduce a slightly a minor utility that we have, which is to simulate case classes and tagged case classes. So I'm creating like an error type, error A, let's say, or bad number. And here, the reason why I'm adding this tag, this is first of all equivalent to like write a tag here and specify additional fields. So it's an alternative syntax which behind the scenes uses a little bit of a trick. Actually, we want to have a number. It automatically implements hash and equals if we do it this way. That's another thing that JavaScript doesn't have. We have a custom symbol type and a custom equality comparator that actually does equality comparison as a normal language with same principles should.
I know. I think I saw you responding to someone on Twitter about toString not being the best way to compare two objects for equality.
Yeah, not the best way. Absolutely not the best way. But it's a funny thing. It's no way at the language level. So every single solution is wrong in multiple senses. Even the custom object symbol is wrong at some levels because it's not a standard of the language. Being not a standard of the language means like what happens if you want to compare arrays. You're either gonna patch the original array prototype, which is gonna add a property on every single array you ever create, which kind of a bad practice, and it's gonna be a mutable plugin to sort of load because you have to actually patch the original array prototype. So when a new array is created, it contains that that specific symbol. So kind of in some patterns, I would say we are picking the less evil possible. And in some cases, the less evil possible is still evil in if not used properly. But I guess that's kind of standard for any language. I mean, sometimes you explicitly make choices that are sort of unsafe if used in non-proper, in improper ways or in unexpected ways. Anyway, let's make this bad number case. So we have a number n, and otherwise we say e dot succeed n. And the type inference now properly tell me that this can fail for the type bad number, or either it's going to return a number as the output. And here now, to start to see the union types in action, I'll create a second error class, which is like bad number or wrong input that simulate that this is a function that starts with an argument p of type number, and this is like summed to the result, just to make some mess and simulate some cases where we might actually get into errors. Anyway, this time it has to fail for, we said, wrong input. Wrong input in this case, we can take a look at the return type explicitly says A or B, which is kind of straight.
And they're not part of the same sealed trait hierarchy, so that's quite lovely.
They have nothing to do with the two. If you mix those using variances, you're going to end up with an any, most likely, unless they have common extensions. Or in some, it's strange because in some cases, Scala 3 actually sort of suggests that a variance should be sort of unionized as the union. It's not in every case, which is kind of weird. Why not in every case? Given logically the union should be the minimum where you have an arrow pointing to any other. It should be the universal construction. So maybe with a few bug fixes on the compiler, maybe it's gonna be automatic. I'm not quite 100% sure. I would still, I think, prefer to have the types without variance and explicitly saying unions and intersections at every combinator for totally different reasons, and that sometimes those types are really unrelated to each other, and having them unionized to the same is kind of it's forcing the type signatures. You don't have so much clarity on what's going on in some type signatures, in some function definitions, because the types are sort of meshed together on purpose. It has advantages and disadvantages. Of course, TypeScript has pseudo variants. So, for example, this won't complain if instead of passing an unknown environment, you pass an environment that has a specified type. It won't complain. But on the other side, it will not automatically unionize stuff. So you do have to specify, like the definition of chain. We see it has explicitly, here I have to make it a little bit smaller. It takes a function that returns an effect with R1, E1, A1, then takes an effect. This is your self. In your case, you have from the seal trait. In my case, I take it from a pipeable. So this is a curried function. Pipe works left to right. So in this case, that the thing that is on the right here will be left to right used in pipe. Sort of awkward at the beginning to look at those types of signature. But here the key is we use different types for R and for E, and this signature sometimes to read, it's kind of more clear, because you're saying, okay, I have an effect which does that, I have an effect which does a different thing, and you have something in the output types that is a result of sort of combination of the two inputs. Sometimes you do want to have relationships, like there are cases, for example, in the schedule data type and in other data types where that you really have to logically relate. And then I believe like variance is the most closest form in which you could actually express the concept you are trying to express. I do believe every language is kind of an approximation of the concept you're trying to encode. It's never one-to-one what you actually think. There's already always this sort of in-betweens. Anyway, that's the result. The types union properly together. You might ask, how do we handle just one of those? And here is where structural type system sort of starts to shine a little bit more.
You're gonna make us jealous.
Sorry?
You're gonna make us jealous.
No, come on. Catch tag. At least one or the two errors. I can say, okay, it's a wrong input. I have the wrong input. And succeed. Number at this point in time, surprise, surprise, it's no longer there.
Awesome.
That's right.
Which, that wise, I believe sometimes it's still very safe to use kind of inference, because if you have this constant partial erasure in introduction of parameters, then sometimes it's really the concept of a function when you're handling errors in one you don't want to propagate. Or, for example, in effect, you're almost never gonna end up with a single or with global error types. You always go as granular as possible, and maybe at some levels you remap it to a more general type. Like if you're building a library at the lower level, you keep as close as actual concrete error types as possible, and only at the end you say, okay, for these cases I return a common error type. But anyway, there's a lot of mapping and handling or providing partial environments. And the good thing is, if you don't type everything, if I add a new error condition, the compiler is gonna complain at the highest point where the thing should be handled. So I'm not saying don't type everything. Type what makes sense to be typed, and basically the compiler will tell you in the point. You will not have to rewrite every single signature in between an eventual hubspot where you manage kind of errors of a subtree. And this in app code sometimes it happens frequently, that you add a new condition and you don't want to manage the condition like in the signature in just the parent, but the point where you actually want to manage the error is like 10 places above. If nothing is typed and only the 10 places above is typed for very logical reasons, the error is going to be at the top side instead of being progressively at the bottom, forcing you to add types one and one. And this also kind of in a more general manner, in a sense that happens much more frequently, is you decide to extract a piece of code to a service. So you decide, for example, to extract a set of functions in a specific service, then you use those services, and you only want to provide the service at the top. If you have every type signature explicit, you're gonna have to either have like widened environment types from the root, or you're going to have to change a lot of sequences, because every time you add a new service at something that's used at the bottom, it's going to propagate up to the top. If you use inference and don't overtype, there's going to be only a few places where those changes are required, are in effect. And this, I believe, is another thing you can express as a developer. Okay, in this case, I want the types to work in this way. In those other cases, I want to borrow the power of the type inference to help me in avoiding those definitions. I think in the same sense as like John has said last time for one of his last conferences about the type classes. Type classes are good in abstractions. Concretion is also a weapon, and we shouldn't disregard any of the two. They are equally important for different goals.
Yeah.
Which is kind of a principle which I believe it applies to multiple things. One being, for example, variance and type inference. Type inference has nothing wrong, variance has nothing wrong. Mix the two, it's gonna explode. That's stuff like that. Let's see how this would work on a little bit of environments. But before doing that, I want to add a new intermediate syntax. And the reason I'm showing these different syntaxes is because effectively there are places where you would rather prefer using one or the other. There are really good reasons. So before we get to the actual part on the environments, let's take a look at how we, for example, refactor these using another do simulation, but which is slightly more powerful than a plain do simulation. And it uses the generator syntax from TypeScript with a little bit of a trick, which I would not go in details because we have to look at the Scala 3 ideas also, and otherwise there won't be any time left, and I do want to write some Scala 3 too. This, for example, would be rewritten kind of the same in terms of this is like you could think about this as like an async await sort of stuff.
Yeah, that's what I was just making me think of.
Sort of. Slightly different, but this is a fully imperative way. Inference still seems to work, but now you have the full power of plain imperative JavaScript. So you can write if conditions. You could say if x plus y are greater, then yielding another effect. Why this is complaining?
Do you need those brackets at the end there? Oh, there you go. Yeah.
Just wrap that parens. Is it confused as the?
Is it confused by this? Yeah,
Hey.
It is confused by the parentheses. But the point is you can kind of write those yields in even awkward places, like write a while condition with a variable that depends on an effect. So it gets crazy. It's extremely expressive in.
That's a little bit of our feeling with the async await. Of it looks cool, but like, yeah, if you want to do like serious stuff, it gets a little crazy.
It gets crazy, but in some models, actually, this sort of imperative syntax is kind of the best description you could approximate.
Yeah, definitely.
Not always the case, but sometimes wonky.
Can you, what if you do, because I never tried doing this type of syntax before, but if on line like 17 and a half, right, between 17 and 18, if you conditionally or maybe just threw an error or something, does it propagate the error types as well? Will it still union errors? Can it track that at all, or because they're not connected any longer? Can it only sort of track the results of?
Let's do that. So in this weird condition, we are failing for reason X.
Mm-hmm.
That is traced accordingly.
Wow. And on the next line, if you just like return X plus Y, right? And so that was just something that like sort of, so not even as like the final statement, but as sort of a
in the middle.
Like if that were just sort of like a side process, you know what I mean? Like instead of even having else return one, just have return one on the next line. I guess that maybe that doesn't even make sense. Because that would short circuit if it were in like a for comprehension, right? It's the failure. But what type do you have now? Does it still have potentially, whoa, okay, that's cool. I don't know.
As expected.
Yeah, that's awesome. I don't even know how
the only thing you can't do, and not because it's impossible to encode, but because it doesn't work at the type level, is you can't do try catch. And this doesn't work. It's not implemented. It would be possible to implement, but it doesn't work because TypeScript and JavaScript in general, you can throw whatever. And there's really no way of instructing that this type in this scenario can be only A or B. So it's kind of a limitation, and that means error management shall go out of the for comprehension simulation. And I believe it was never the intention to make error handling as part of a for comprehension anyway.
Sure, no. I mean,
you wouldn't expect that to kind of not be designed probably.
Yeah, that's pretty crazy. How does that type inference even work? I mean, are you manually rewriting this code into something, or is that just kind of what the function does?
Look, that's insanely complicated, but the reason it's insanely complicated is I've kind of jumped and I've hidden stuff on purpose because I didn't want to go into many details, but there's an asterisk here.
Of course. The asterisk.
Yield and yield asterisk are two different things. All of these types don't work if you don't use the asterisk version. In the asterisk version, I'm actually merging generators. So in theory, what happens is this function that I hiddenly passed through here as an argument is an adapter, and an adapter transforms an effect into an effect generator. So that's like arrays of arrays of arrays, streams of streams of streams, generators of generators of generators. Obviously, this is going to be a single value generator that simply returns the syntax, but this trick has the compiler do widening. So the compiler is going to widen statement by statement. It's going to produce a union as a return. And in fact, if you see the type here, the generic parameters are actually represented as a union. So what you end up actually having, the internal function returns a union of all of those effects, which have been progressively laid out in the imperative style. At that point in time, via a sort of weird, strange type level manipulation, which would be similar to one of your match type with dynamic inference and a trick to make stuff contravariant and covariant. You see the infer is in two different places. One is at the input level, the other is on the output level. All of those are sort of tricks, undocumented, not really TypeScript standard. So
you're folding over the union types and then generating a single type, yeah.
And generating a single type as
intersecting all the errors and unioning all the environments.
There would be a different way to do this too, which is actually forcing, like, I could force these to extend specific stuff and infer R infer E. And that's just that. And saying otherwise.
Very impressive.
Never.
Otherwise, never. Yeah, I had the zoom thing on top.
Oh,
So,
yeah.
yeah, I didn't, I wasn't properly looking at the stuff. And okay, that doesn't extend. What have I done? Extends effect RE. AF. Any, which is a more powerful version of Unknown, totally unsafe. Anything is assignable to any. That type of thing would most likely work in the same way. It doesn't, obviously. I probably messed up something. It's not a
That's
good...
That's a lot to live code right there.
Yeah, I mean, it's kind of normal to mess up stuff when you're doing live coding in a compiled version and not even being sure of what you're doing.
Exactly. But that's crazy.
But anyway, those types are converted in a same way after a good degree of attempts and progressive failures for like 2.5 years in general, but now they sort of work. And
Yeah.
at some level, it's impressive because that's type inference. I'm not saying that because I wrote the code. I'm just,
It's
yeah.
really, yeah, from the outside, definitely.
Anyway, that's we're still playing with outputs. Let's start to play something a little bit on the input side, so like services. Here is another place where let's start with how you would do it in ZIO terms. So the definition first. Let's say we want to build a console like a math service. And we want to have in the math service an add function that takes 2 numbers. And it returns a non-failable IO or a number. So this is the same type you would define a trait. In Scala, we define an interface. In TypeScript, the second aspect that you guys have implicit and we have explicit is the tag. And this creates the tag data type that we use to access. Let's write, for example, the access helpers, as you would manually do in normal code. So add X number, Y number, dot access service M, math service. I pass the tag rather than writing the types. So I'm borrowing inference. I have to pass the tag manually anyway. So that was kind of solving 2 things at the same time. And we add.
That's really cool. Yeah.
Kind of still boilerplate to cut, but still, let's use this function. Let's say if we don't fail, we want to return let me show another thing. We saw here the access service thing. Now I can use directly this function and add 1, 3, or add x and y, and the return type you would have has math service at the input level. There is this adapter, and this adapter can be exploited to do other weird stuff. At the type level, the only thing that counts is that at the end I have an effect. To start with, I can actually start with other things. For example, I could yield the tag directly. And this gives me access to the add function straight away with no need.
Ah, very cool. So
this gets extremely helpful when you're, for example, building layers, where you want to have some sort of dependencies at the layer construction level, and you don't want to have those dependencies at the actual implementation level.
Yeah, that's kind of cool. The async await, you're almost like just importing the functions from the service.
Which behind the scenes is exactly the same thing as doing t-dot.
We like to make our things nice.
But you like to kind of compact stuff. Cool. And things get awkward when you realize you don't do this only with tags, but like I can yield an option in an effect thing, and this will kind of now raise for a no such element exception. So really this is kind of exploited to sort of lift speaking in general terms, is a lift of a natural transformation to a monad effect.
Yeah.
But yes, it's obviously not at that level. It's a much lower level, and you do it by hand in specifying this adapter function, which for effect, for example, we have two potential generators. One is the one we saw. The other is a generator which behind the scenes supports managed. So it allocates a release map at the beginning, it runs your child, and it pops up, and it closes down at the end. So effectively that enables you to sort of yield managed resources, which will be linked to the lifespan of the current running event.
You probably know ZIO pretty well from, I'd imagine, from re-implementing it all. That's crazy.
Look, I've seen every single line of ZIO. I wrote every single line of ZIO.
I might have seen more of it than anyone, actually, because it was written by.
Look, at some level, I think it's a great way actually to learn a library, to try to re-implement it in a different language. And I have to say, it was one of the best experiences in my life. It's like reading a book, a very well-written book, and where every chapter makes sense, well connected to the previous ones. So it is an experience that I would probably suggest a lot of people to actually dig into the details of how those guys actually are implementing stuff, which seems crazy if you take a look at it. And at the end, it's actually kind of very simple behind the scenes. The ideas are very simple. The implementation is complicated, but because you support a number of features that kind of explode. ZIO support, I mean, one of the biggest thing was the fiber monitoring stuff. That's insane at the level of complexity tracking. So there are places where really it's a lot complex, but the details are complex. The idea per se is not complex at all, and that's an amazing thing. And I find more powerful data types are usually simpler data types. It almost sounds ridiculous, but the new stream module with its 7 type parameters, the famous set defunct, it's still much simpler than the alternative. It's a simplification of a model, which in other terms would require multiple data types disconnected. So really, yeah.
Well, yeah, you can't assume things when they're just type parameters. So yeah, you can only do the things that fundamentally make sense with the structure.
Yeah. Anyway, this is the generator syntax.
It's really cool to see this.
The other thing I wanted to show as a matter of specifics here is actually we got to the point of having a fluent API. So now you can have actually,
nice.
if I this x2, let's see how would I inject a layer. Yes, I have to construct a layer.
I like all your little auto completions as well, your snippets. That's
yeah, that saves a lot of time. Let's say from effect, this is we want to provide a math service. We want to make a concrete implementation of the math service.
Oh, that's kind of cool how, yeah, well, it's the structural typing again, but you didn't have to do like trait math service step add. You just did add because that's what a math service is. It's an add.
It's just what that is, but clearly that should definitely be called like const make live math service, or actually live math service more appropriately. And those are layers, the layers you're familiar with in ZIO, including a good degree of operators, which are kind of working even in a stranger way, because I know Kit has worked a lot, and this is gonna look totally different in ZIO 2, and you're gonna have a lot of automated stuff. But in ZIO 1.0, it was kind of a pain having to like put together. We are all aware of that. It's kind of a holy grail solution, except for the fact that it's painful to use in a specific sense.
Yeah.
Which is beautifully going away with ZIO Magic getting included in 2.0, and really great to do that, because it was one of the most, I believe, boilerplate part and kind of friction aspects. Here we have structural type system, we can match and stuff, so we have more like we can provide from the right to the left, from the left to the right, adding to the input to the output. You can mix and match what you do to actually shrink.
That's cool.
And behind the scenes, they are encoded precisely in the same way as you have in ZIO. So that's a layer. The other way to create a layer, given that we have a Fluent API, is if you have make live math service, which is in this case, it would have problems. I'm introducing a little bit of a problem to solve it in a minute. You can say 2-layer math service. This is actually still live math service. As before, works in exactly the same way, but we have the 2-layer. One thing we can do in TypeScript is we're kind of repeating. Here I could say yield a math service, but there is kind of manual typing around to be able to get something that works. Sorry?
It knows what that function's supposed to be. When you tell it it's a math service, it knows those are in, so you don't have to tell it.
If you tell it, it knows it. But usually, at least I don't like to write a lot of things manually that I can abstract.
Yeah.
And this is the other place where the real idea is not to define this manually at all.
Yeah.
Define the concrete implementation and derive that from the concrete implementation.
Well, that's really cool. Shall we talk about some of the Scala 3 stuff? I'm cautious. I want to make sure we hit that because I'm curious to see it too.
Absolutely. That's gonna be really really fast. I just want to derive this type automatically and
perfect
definition. It's gonna be a one-line change. So I'll remove this from here. I'll move those. Actually, I should move these above. So in this case, we are effectively not specifying. We are defining here the actual types.
Yeah.
This is a make now. So this returns effectively an effect which creates the service. This might access other pieces of environment, might be managed, might do all the things you expect it to do. And here we can extend, can use the same type level trick that we saw before. And at this point in time, the concrete implementation would be two-layer math service.
Nice.
And underscore A is kind of a type level function that just gets the type that's wrapped inside. Oh, it gets the A value out of the ZIO. It projects.
It gets the A value from whatever matches this structure.
That's cool. Yeah, that's something maybe we can do
with mesh types. Unfortunately, I wasn't successful in doing that.
Okay.
that I wasn't successful in doing, and there are still a little bit of problems around. What is this? My service is used before the declaration. Of course, I have to declare the type before. But apart from that, everything else is compiling and working as expected. Let's jump on the Scala side. There's not going to be a lot of too many similar things, but this is my starting goal. What I would like to see on the other side. I've borrowed a lot from you guys in building this. If we can give even the 1% back, we would be extremely happy.
We'll take anything we can get.
Let's see on the Scala side. The directory is locally called crazy, and inside of that I have a sub project and an SBT project called crazy indeed.
It's not even crazy, it's crazy.
It's crazy.
Crazy things. These are the crazy things of the crazy things.
No, it was a funny experience when I actually created this project, because the last time I created a project in thinking, yeah, I can port ZIO to that. I ended up succeeding in that about 2.5 years ago after. And when I said the same in Scala, okay, I'm not gonna do that. There's no way, but logically and emotionally, it was kind of the same rush. It's a different discovery. So I started with an extremely minimalistic thing, not even linking to ZIO. I've implemented an extremely small local driver just to test that the actual things I'm more interested in at the type level. Obviously, no other project is ever gonna re-implement any of your data types in Scala, and an eventual release will obviously use your base original source with a sort of API in a different way. But that was also a reason why to study a little bit of Scala 3. So that's you're not going to see an integration with ZIO. You're going to see a mini ZIO for that. I'm
excited by what I'm saying. So yeah.
So what's going on is on the Scala side, kind of trying with enums, with the new enum definition, and you see I have to specify the variants on the parameters. This is kind of for a bug, which is open on the issue tracker, because ideally, here I would prefer it to be like that. So I would prefer those types to actually do not vary by default. That's a personal opinion. Yeah. It's a personal assumption, and guys, I've seen comments on the stream data type. Sometimes we fix that, and we fix that because variants didn't work with inference, probably, or for similar reasons. My finding is if you have good union and intersections, the purpose you're using variants to address is kind of already addressed by the fact that you have unions and intersections. Anyway, it's not a big deal to have the variants there. It was just sharing opinions and general.
Yeah, totally.
Please take whatever you want and ignore whatever else.
Yeah, no, I'm all eyes on this.
So apart from this is like the plain methods within the objects using an enum style. Those could be extension methods too. And you might notice that here there is no run function. The run function is actually on an extension method that requires the environment to be known, which is a nice aspect I figured about. It's one thing I like particularly about Scala 3, those types of extension methods. They look much cleaner compared to like an implicit class that we used before to provide additional pieces of syntax. Those extensions can be effectively a little bit more flexible. Anyway, those are low-level pieces of the encoding, and potentially you want to get rid of everything and build it on an abstract class, as ZIO is, because of binary compatibility and another 100 of probably potentially very good reasons. The funny aspects is I've done it in Scala 3 natively, and honestly, everything seems to work decently well. So it's, as you would expect, it's a seal trait, it's a union, it's an additive of multiple data types. If you see here the data types, guys, we are mixing effectively the parameters using unions and intersections. For example, a flat map, we take a ZIO, which is the current running operation, plus we take a continuation, and the type of the continuation and the type of the original have kind of no relationship whatsoever to do with one or the other. And I feel this model very, very close to what you're actually trying to model. I'm doing something and something that's dependent on the result. But errors and environments they might require or they might produce completely different stuff. They are per se not related. So logically, I find useful to have these separations of the types. Anyway, that kind of defines the basic material for the abstract syntax tree that a ZIO would be built on top. Obviously, this is a very dumb set of primitives. It doesn't support anything asynchronous. It's a minimized objective. It's very minimal mental model, but at least the type level part is kind of correct.
Yeah.
And you see the succeeding, the failing, using an environment, providing an environment. Probably this is not necessary at this level, but there is a bug which I'll show, and the reason why I sort of push it down one level below.
Yeah.
Anyway, that's the set of members. Then we simply create a tag. This is purely type level thing. Exit, I simply use like an either. I haven't rebuilt any of the codes. In effect, I have the full codes, but here I obviously didn't want that type of complexity. And here we get back to our beautiful style of writing stack safe code, where we are dropping type safety as soon as we enter the things. So okay, I have a continuation frame, which is kind of handling only fold map and flat map, sorry, plus an unsafe run, which basically it's a simple, small, stack safe synchronous driver, which you might compare to maybe the driver you have in ZPure without even paying attention to the details. there's probably bugs here at some places. Even though I've wrote this kind of stuff 100 times and even more, I believe errors might be everywhere. Which anyway, it's a plain stack safe interpreter to avoid strange recursion stuff. And here I've said the services, rather than actually using a generic thing, I use directly a map, a tag to service map. So everything that goes in is a service through a tag. The reason I've done that is because of a bug. I don't know if this might be an idea in general. I don't think so, probably. Avoidable would be better, but that's kind of the stage, the less buggy implementation I found so far. Anyway, let's see the plain definitions. It's like succeed, fail, and use. The three basic primitive. Plus, okay, here, given an R, we take an implicit tag. This is a different thing from the actual usage in ZIO today.
You're kind of building in more the idea that the R is always a service,
Yeah, I'm saying R is always a service. But I repeat myself, this is for a bug, so I don't really want to saying it in. It's not even sure it makes any sense. The most interesting things are, I believe, the injection of environments and the catching of specific errors. And catching is a complete hack, I have to say.
Well, it's interesting because I see for both of them you're using this like implicit evidence R2 and R3 to R. Is that something that just the Scala compiler can automatically derive, or are you creating instances?
Look, if logically, and this comes from TypeScript.
Definitely.
Having wrote this line of code, it was the most natural thing I've ever wrote. Starting from the TypeScript thing, but I know it might be weird. This is basically an implicit evidence. This is going to be an identity. Okay? If type inference works, the only function that respects those constraints should be an identity.
No, it makes all the logical sense in the world. I'm just wondering if the Scala compiler is actually going to do it.
Yes. The answer is yes.
The underscore colon underscore, right? The subtype implicit, that extends function. So it's probably just using that implicit.
Yeah, exactly.
So, doing. It probably would.
They can do that with the intersection types, and that's a very interesting way to do it.
So that is actually to infer the reminder of what we're providing. Because given R.
And so will it eliminate that without you, I mean, maybe we'll see it in a minute, but it'll eliminate that without you specifying the return type there?
Yeah.
That's very cool.
Yes, that was the objective to start with.
It's a great objective.
So fundamentally, here we have an R as an input, and that specifically has nothing to do with the environment we are providing. Here we could specify if we wanted to not have R contravariant, it would be reasonable to say that R2 has to be a super type of R. So you could have some sort of subtyping relationship between the two. That it would make sense in a case where I have variants running. I might want to provide stuff that it's not actually required to provide. I might want to provide additional stuff, maybe environments which are optional that don't appear at the type level. We have played with concepts of like optional environments and stuff like that, like database transactions sort of are a thing that might be there or might not. So anyway, to cut it short, R2 has nothing to do with R, and R3 has nothing to do with R. The only thing we know is that R2 and R3 are kind of convertible to the original R, which means they could be exactly the same thing. They could be something slightly more, but not requiring like an identity. This is a weak Leibniz proof. We are proving only one side of the equation. We are not proving the other. Obviously, proving the other would require me to sort of remove the variance, because then R would appear in a covariant parameter. To cut it short, surprisingly, this worked. I was as surprised as you are. It's like, how in the hell do I express this? Feels natural, and it effectively worked. I couldn't sort of find the same logic and idea for catching partiality. So for catching partial environments, I had to be more creative. And
I mean, in a way, you've got the similar idea. The evidence is, I mean, it's literally the code. You flip the arrows and you change the products to the sums, and you have exactly the same thing.
Look, it's speculative. It should exactly be the inverse. So on one side, you're treating inputs. On the other side, you're treating outputs. One is the dual of the other. If the mathematics behind the scenes is still satisfied that you think should work, pretty much the same way. The point that I kind of didn't, well, it was not obvious from the start, and what I believe is a hack, and potentially it's unsafe. It can be used in unsafe ways. So I'm not 100% sure that you couldn't exploit it to sort of let compile code that shouldn't compile, or think you are erasing a type when you're actually not dealing with that. But you know, all of those are edge cases that you figure only if you're trying to force in that direction. They're not on the plain happy path of development experience. Anyway, let's get to the actual usage of stuff. This is public on a repository already, so you can take a look at the repository on the meetups group later on to play with.
Yeah, this was awesome.
If you want, but anyway, catch sum uses a different trick. We ask a partial function. That would be a catch sum like in ZIO terms. So you do like filtering with ideally a match, a pattern matching thing. But then you return not only the effect, the IO ZIO that deals with the error, that recovers. You also got to return the error itself, because I have to have type level material to know what actually did you handle.
Yeah. That's a great idea. Yeah, that makes a lot of sense.
Yeah.
It is hackable, because obviously this is matching types, so I could widen things a little bit more to make it break. But to cut it short, at this point, I have enough type level material to be able to write an implicit evidence in the opposite sense as before, as Adam noticed correctly before, and the whole thing is exactly the same. We merge the environments, and we return the reminder of the error. Surprisingly, this works. And let's take a look at the the actual usage, which I don't know why I kind of like. I don't know why, but I kind of like it. Okay, so you define a trait, which is a service like a console. I haven't found any proper way to derive types. I guess that maybe with macros or other stuff, I'm not that sure. But anyway, you then define the object, companion object, where I've defined an implicit type. Here, obviously, the implicit type could be automatically derived by Izumi or whatever, like you do in ZIO, where you don't specify the stuff manually. Anyway, this has a tag, and this is an access. This is an access function where I'm saying, okay, access the console and access put line on the console. This, as you see, correctly infers console, nothing, unit. This doesn't infer has console, which is what we would like to have, ideally. If you have a generic environment, you might have different shapes. You should distinguish between something that uses the service pattern and has data type from something that is actually not. So this distinction is probably something we would like to have if we ever get it working, but I believe the Scala team actually will. They are investigating the issue, so I think that was a reasonable. They are expected to work, so they're gonna get fixed at some point in time, but that's at least my hope. Anyway, here I'm creating a second service, just be nice and play around with two instead of one. And I'm also defining two different types for the error scenarios. And I'm writing a simple program that uses the console and that uses the math. And this program effectively infers to something that we would expect.
Mm-hmm.
This is where it gets interesting. I've introduced the types, and here let's be on in the matching part. So let's deal with some errors and let's deal with environments. Let's not provide everything from the start. I have to save.
And you eliminated the array there, which is very interesting.
And let's start by that.
Yeah, the unification of the value types is a little bit weird. I mean, it's accurate. It's just a little weird, yeah.
It's accurate. It is a little weird, but it is a bug.
Okay.
So it is supposed to be removed. It shouldn't duplicate.
Yeah.
But anyway, this now we want to deal with a single case, and we effectively match on that, return precisely the error, as strange as it might sound, but this effectively strips out the error. The only thing we get with an awkward type here. And if I remove the variance, the code stops from compiling at all, but not for logical reasons. It just goes in a compiler crash. And it's actually a thing that you spotted it on Twitter a while ago, where I posted a snippet of Scala 3 and you said, that looks like a compiler bug. It was. Anyway, that strips out one environment. It's reasonably nice to use. Imperfect, but reasonably nice to use. And let's progressively inject a console, and we have the reminder inferred to math.
Mm-hmm. Now, with the catch sum, is it reliant on, like, you're using, I would say, a little bit of an odd syntax there with the E and then the E pattern match? Like, if you just do that as an inline match, will that still work?
This way?
Yeah, and then delete the match and just make it a bracket. So just do catch sum case X error, and then delete that parentheses.
There's absolutely no reason why not to do it this way. It works exactly the same.
Nice, very nice.
I believe I was just writing with TypeScript in mind.
Yeah, sure, no, sure.
When I wrote that, I have to be sincere.
Nice.
It works pretty much as expected. And he's now complains because obviously, I can't find these with
the math. Right.
Math is missing. Right. And whenever I inject math, that should stop complaining. It's
awesome.
Actually the final,
really cool.
Final result. I believe these, if nothing changed during the last week, this should even work. It would be a plus if that would work. It will definitely close my presentation in a decent way. I can't guarantee that.
I think it's going to be putting my money down. It's going to work beautifully.
Compiling.
Also, it must be true.
If it compiles, it must work. What's going on? Compiling command. Yeah, hello world, result 5. Yeah.
That's really cool.
That's really running Scala 3 with erasure on both.
Yeah, well, I'm definitely spending some more time playing with this, but this is really cool.
If you use a has, the bug, at this point, I can't tell what the bug is. If you use has and you inject a single one, then apparently Scala still finds an implicit evidence of this pattern as console and as math.
Yeah, because has is invariant, and apparently you're not supposed to be able to have I don't know. There's something you can't extend the same invariant type constructor multiple times. Apparently that's invalid. I asked about a question a while ago because I was trying to make a match type for intelligently concatenating different type constraints. But anyway, apparently that's a limitation. It seems weird, and yeah, it would be great if they could just throw away.
What is the repository of Scala 3 that I don't even remember? Dot T, no.
Yeah, no, not that one.
That looks right.
Where
is? Do you guys know where this is? Because I've opened an issue and I just realized they've closed the issue.
I would just Google Dotty Scala.
It's lamp EPL/Dotty. Oh.
GitHub/EP Dotty. Dot.
I just pasted it.
GitHub. Someone just pasted it. Yeah.
There it is.
I'm just so curious because I see the issue actually got closed.
Oh yeah, was it will not address or?
Oh no, it's still open. Okay, yeah, it's still open. I thought it was closed. Anyway, this issue lays out both.
It's 12077. I wonder if that was me or Kit.
So that's probably someone's talking about ZIO at some point. And it's still an open thing, so it's not closed.
Oh no, it was one of our users. Yeah.
It is one of your users, guys, but it seems to be like they are not doing it. They are only doing it for like kind 0 types. So
yeah.
but that's not the right thing to do because you could compose multiple stuff, not necessarily. I mean, the problem appears not only with has, but with every multiple level. Yeah. But hopefully, once those two are solved, you can have the same type of encoding as you use in ZIO. Without that, you're gonna have to use a plain intersection type.
Yeah.
And otherwise, the bad happens, and effectively Scala finds, which I believe what happens behind the scenes is actually this is going on.
Yeah.
Which is an absurdum,
yeah.
Which is an absurd, which can never be called, and by definition, every function is an absurd that it can never be called.
Yeah.
So because of this type inference issue, they actually think there is an evidence stripping out. But apart from has, sort of work extremely interesting.
Really cool, yeah. Well, I want to be respectful of people's time here, so maybe at this point we can open it up for questions from folks.
Yeah, I have nothing else really.
Yeah, I actually think I have to head out a little early myself because I've got something in a few minutes. So I just need to prepare for that. But thank you so much, Michael. I'll let you guys close it out here. But
definitely.
Someone else is the host, and so
I'm just
recording. Make sure to end the recording before and all that stuff. But
yep. Let me just go to Discord.
Thanks, Kit.
Ask a question.
All right. Thanks, Michael. Great to meet you.
Great to meet you too.
Take care, Adam.
Yeah. Talk to you a bit.
Okay. Is there any question that you guys haven't already answered?
So I think there was an interesting question about the catch sum. Could we do that when we have a third error type and see what happens there?
What do you mean if we have a third error type in Scala?
So 27 case class error C.
And then failing for
error
C.
And now let's see what like our type looks like. Is this still?
Oh, wait a second. Why is this now object?
Well, so I think what I think Feller was maybe astutely getting at is I think our case above in the catch-all may have been like overly specialized to like the Scala compiler may not be able to see that like when we have the when we have A or B, that A itself could be, you know, A or C, may not be able to kind of go through that.
It did it in multiple occasions. And
okay. So yeah,
I think this is actually a problem of specifying the variance explicitly. I think it comes from that. Because it's not that the catcher doesn't work. It's not the problem on catching. The problem is on specifying this that apparently, oh, now it works. Sorry, this is.
yeah, because it is the error type where it seems like we're losing stuff.
Yeah, it seems like we're losing stuff now.
Yeah, maybe I wonder if that was.
I wonder if that was the thing. Actually, we did try this with both multiple errors and multiple environments. But it might be a weird.
Yeah, I mean, maybe take out the environment stuff, like if we just focus on the errors.
Yeah, it might. No, that's still no. Error A, error B. Because what I was doing, I was even catching two errors at the same time.
Yeah, I wonder if it's like, oh, if you, because that like still maybe leaves a situation where it can reduce it to there's either one thing that's not being caught or there's a set of things being caught, and maybe it's
yeah,
not.
I did try both of the things, but then I think I got the compiler to crash. I believe this is due to actually the forced variance annotation.
Okay, well, yeah, I mean, I think overall,
this is my really... this is my belief, but
yeah,
yeah, buggy.
Yeah, it'd be really
implementation.
Look at that, but I mean, I think regardless, like this is a really interesting direction, and it'd be cool to explore this more.
And there might be other ways to sort of
code this, sure.
Yeah, I mean that's probably not the 100% the best.
Yeah.
I'm curious now if on this encoding even the.
If we got a third service or something.
Yeah, if we got a third service.
Yeah.
Because I had to force it. I had to add variance forced in multiple places where I didn't want. That's line 2, line 2, line 2. Console 2, or 2. So it is in this way. It still it only requires back the console 2.
Yeah,
so at the environment level, it works as expected.
So there's something where we were maybe a little too fancy or not fancy enough right now with the catch stuff.
There is still a bug on the union types. Yeah. If I can show you something else, which is why I think those two are actually related. If I remove the variance from here, so I make it invariant.
Yeah.
What have I done? Now it appears to work. I can't reproduce the bug. Okay, I apparently cannot reproduce the bug, but fundamentally the compiler crashes in a bad way, and
in a very ugly way.
this is what you end up with.
Yeah.
And at some point you see this E2, which is supposed to be a generic parameter, which ends up being in the
tuple,
in the concrete output. So there are definitely strange strange behaviors.
Yeah.
Yeah, you see like here it's duplicating error A, error A, error A,
Some
error
of that
A.
just doesn't clean up. Yeah.
I hope like in 6 months to a year time,
Yeah, totally.
hopefully that in TypeScript it took ages to get to the point where everything was actually working as expected.
Yeah. All right. Well, again, I want to thank you so much for joining us, and also thank everyone who joined today to listen for taking the time. But I'm really excited.
Thank you, guys. It was exciting to be here. Really, I am
Awesome.
very excited.
All right. Well, have a wonderful day, everyone.
You too, guys. Thank you very much.